Now let us discuss dielectric properties of insulating materials. First we will see introduction of the dielectric materials, basic properties of dielectric materials, and then slowly we will go ahead. So the syllabus content of this dielectric material, it is mentioned in curriculum like static field, parameters of dielectric material, means definitions we have to learn, dielectric constant, dielectric moment, polarization and polarizability. So these terms are familiar to you, but we'll see in details. Introduction to polar and non-polar dielectric materials. Mechanisms of polarizations. There are different types of polarizations. So we have to learn different mechanisms of polarizations. Electronic polarization, ionic polarization, orientation polarization, descriptive treatment only. So mathematical formulas or derivation is not required for polar and non-polar material. But Clausius-Mossetti equation, we have to see derivation, that piezoelectric materials, pyroelectric materials, and ferroelectric materials, dielectric laws and loss tangent, and concept of negative tan delta. So, unit number 1 on dielectric insulating materials is this. These are particularly dielectric materials. Okay, so you have to see this course curriculum of lectures 6 hours. Now you have heard the name conducting materials, insulating materials, magnetic materials, semiconducting materials. So you are aware that conducting materials means they will be used for conducting wires. So conducting materials are those materials who allows the flow of electric current very easily. Resistance of conducting material is very less. So if you'll see insulating materials, the materials which are used to insulate the electric current are called electrical insulating materials. Means such a materials will not allow to pass the passage of current through it, but they will be allowed to insulate electric current. So the material through which current is opposed, current flow is resisted, or they will insulate the current. Materials will insulate the electric current. So what are the insulating materials? The materials which are used to insulate electric current are called electrical insulating material. Insulating. So name only implies it will insulate electric current because we are electrical engineers. So we are mainly bothered about the current, voltage, current flow. So through these materials, current will not flow, means they should not allow. Current will start flowing at certain conditions, but in normal conditions, current should be insulated. So if you see dielectric materials, so name only will implies die and electric. So die means two. Electric means the poles will be there. Two electric poles will be there. So how you will define dielectric materials? The materials which are used to store the charge are called as dielectric materials because die means two, positive and negative, positive charge and negative charge. So if you see material, you can observe where is positive charge and where is negative charge. There will be some distance between positive and negative charge, and therefore it is called as dielectric. Means two charges you can see, distinct two charges you can see. But when you will see insulating materials, you will see that the center of positive charge and center of negative charge will be coincident. Two charges are there, but they will be neutralized. So atom as a whole will be neutralized, and center of positive charge and center of negative charge will be coincident to each other. But when you will consider dielectric material, positive charge and negative charge will be displaced from each other. There will be distance between the two charges, and you can see distinct two charges, positive and negative, and therefore such materials will be called as dielectric materials. So try to remember the difference between dielectric materials and insulating materials so you will not confuse with each other. Now all dielectric materials are insulating materials. All insulating materials are not dielectric materials. So you should not confuse. So dielectric material is a branch of insulating material. So if we'll see today, we are just considering in this unit dielectric materials, and then the second unit will be on insulating materials. So what is the difference between dielectric material and insulating material? Dielectric materials are insulating materials only, but only little difference is there. So all dielectric materials are insulating materials, but all insulating materials are not dielectric materials. Now dielectric materials as two charges are there. From the name only it implies what is the purpose of dielectric material. Two charges. So definitely it will be used in capacitors because capacitors are used for storing the charge. So dielectric materials are used for storing the charge. So they will be used in capacitors. Whereas insulating materials are not allowed to pass the current flow, electric current flow. So where they will be used? Wherever you don't desire that current should flow. So they will be used in the transformers, cables, wires to insulate the conducting parts. Because transformers also carry current, conducting wires of the transformer will carry current. But there has to be insulation between that conductors and the core of the transformer. So when you will touch the body of the transformer, you will not get shock. So insulating materials are used in the transformers, cables, wires where the electric current is not intended to flow. For example, consider your house wiring. You are passing current through that wires to the fan, to the light. But how they are coated? They are coated with PVC, VIR. They are coated with insulating materials because when you will touch to your wire, that current flowing through that conducting wire inside the wire should not pass through your body. So you should not get shock. Therefore, covers of that conducting wire should be covered with insulating materials. So through the conductor, through the inside wire, current will flow, but through outer layer of the insulation, current will not flow. So those are insulating materials. But dielectric materials are nothing but insulating materials. But difference is that dielectric materials are used for storing the capacitors and insulating materials are used for insulating the current. What are the examples of dielectric materials? Oil, paper, mica, ceramics. So which materials are used in capacitor for storing the charge? Oil is used, paper is used, mica is used, ceramics is used. VIR, PVC, bakelite are the insulating materials. So try to remember this insulation and dielectric materials difference. So just read it yourself. I'll give you some time. Mute yourself. Whose sound is coming? Mute. Just see and note down the difference because I'm going to play some one competition today and let us see who is attending class very attentively. Okay, who will win the competition. Let us see that. Now we'll see different terminologies. Coulomb's law, different equations and different definitions. So then you know it, just it is a revision. So Coulomb's law you have studied. So force of attraction and force of repulsion. So what is force of attraction? F is equal to product of two charges. If two charges are displaced at some distance, Q1 and Q2 equal and opposite, then they will constitute force between the two charges. And that force is given by Q1 into Q2 divided by 4 pi r square epsilon. So remember these equations to solve simple MCQs. Okay. So Coulomb's law you have to remember. Now where this epsilon is dielectric constant or permittivity, you know it. What is the value of permittivity? And 4 pi r square is the area of the sphere. So this force is equal to Q1 upon Q2 divided by area into permittivity constant or dielectric constant. Okay. Now electric field, second definition, electric field. So what is the definition of electric field? So the region of influence of charges is called as electric field. Suppose two charges are displayed at some 1 meter distance. So what is the influence of that two charge region of influence? Because after if you go away from the charges, you will not feel the influence of that two charges. So in which region you are feeling influence of the two charges? It is called as electric field. And its strength at a point is defined as what is the strength of that electric field? It is defined as the force per unit charge. So it will be force. We have seen equation force per unit charge. So F by dq is equal to electric field intensity. Okay. So the unit of electric field intensity will be joules per meter. So joules per meter is the unit of electric field intensity, and formula for electric field intensity E will be equal to F upon dq. So F you know Q upon 4 pi R square upon epsilon. Okay. But what will be the intensity? This Q1, Q2. So 1 Q will be cancelled because you are dividing with dq. So instead of Q1, Q2, it will be only 1 Q positive charge. Okay. Because see what is the definition. Electric field, it is the region of influence of charges, and its strength at a point is defined as a force per unit charge on a positive charge placed at that point. So where F is equal to force acting on an infinite charge dq. Okay. Next definition, electric field density, electric flux density. So what will be flux density? The flux density is defined as the number of flux lines crossing a surface normal to the lines divided by the area. So when you will consider the surface for density, that surface should be perpendicular. Normal means perpendicular. So that the angle has to be right 90 degree. So it is divided by an area. So if you will assume a point of charge of magnitude Q and electric flux density R from that charge point. So flux density will be given by charge per unit area, and area will be 4 pi R square. So 4 pi R square is surface area of radius R. And electric field density also depends upon applied electric field intensity. So flux density is D is given by Q upon 4 pi R square. And here in epsilon is not there. Okay. So you can say flux density D will be equal to epsilon into E. So when you will see the formula of E, that epsilon and this epsilon will get cancelled, and you will get Q upon 4 pi R square. So you just go on putting on paper and check the definitions. So you have seen. Again, I will tell you because quiz is there. Try to understand this formula. Try to remember this formula, which is just revision, I think. You have gone through this. So again, I will revise. F is equal to Q1, Q2 upon 4 pi epsilon. Okay, remember this. E is what? E is Q upon 4 pi R square epsilon, because 1 Q will get cancelled because E is equal to F upon dq, and D will be equal to epsilon into E. Now what will be dielectric constant or permittivity? You know this dielectric constant or permittivity. So the relation between the electric flux density D and electric field intensity. So this is the constant of proportionality. So you can see epsilon will be equal to D upon E. So where proportionality constant epsilon is called as dielectric constant of the medium or permittivity. So epsilon is constant, and that is the permittivity of the media. If the medium to which electric field is applied is free space, vacuum, you know what is the value of epsilon 0. Epsilon 0 for free space is 8.854 into 10 raised to minus 12 farad per meter. The dielectric constant of material is expressed by epsilon r. Now epsilon is just absolute permittivity. Epsilon 0 is the permittivity of free space, and epsilon r is the permittivity of some material, whatever material will be there. So epsilon r will be equal to epsilon upon epsilon 0. You know absolute permittivity epsilon is equal to epsilon 0 into epsilon r. So relative permittivity will be equal to epsilon upon epsilon 0. So you will just see D will be equal to epsilon into E. Put the value of epsilon. It will be epsilon 0 epsilon r E. And therefore electric field in you can just see this. What will be there? D is equal to epsilon upon E. So epsilon will be equal to, this is wrong. Epsilon will be equal to D upon E. Okay. So dielectric constant of the medium is defined as the ratio of absolute permittivity to the permittivity of free space, and it is unitless. Absolute permittivity is defined as the ratio of Field the density